Hello, welcome to Taxpayer Alert. I'm Al Segala. I'll be your moderator. I'm also president of the Calaveras County Taxpayer Association. And these programs are really fun. Not only fun, but they're really interesting. We cover many topics that all relate to what's happening to our tax dollar. Well, our guest this session is Steve Fairchild, who's the founder of Moaning Caverns Resort. And also, he's a scientist, a climatologist, and a geologist, all rolled up in one. And he has a fascinating story to tell about the truth on climate change. And also, he's just a delightful person to be around. And he happens to be vice president of the Calaveras County Taxpayer Association. Welcome, Steve.
Thank you very much.
Steve, okay, going back, how'd you get in the cave business?
When I was like 3 or 4 years old, I used to crawl into every dark place. My dad was mad. He had to pull me out all the time, and I've been crawling into dark places ever since. I've been in some of the deepest caves in the world, all over the world. I've traveled from China and Korea, even North Korea, all throughout Mexico. I used to take tours from the United States down into Mexico to tour the caves there. And along the way, you pick up a lot of information from the caves, which are ancient, millions of years old, and since there's no weather in them, it preserves everything that happens thousands and millions of years.
That's awesome.
And the growth rings are like trees, but they're not one per year. They're hundreds of years.
I understand they found a hammer made out of iron, not steel, with a wood handle that's 150 million years old.
Very well. Yeah, there's a lot more to this world than
a monkey didn't do that.
Yeah, there's a lot going on out there. And unfortunately, some of it seems to have a political background.
Yeah.
There's a lot of politics involved around global warming and carbon dioxide, and they're selling millions of dollars worth of credits of carbon dioxide emission. You can give money to somebody, and then you can generate carbon dioxide, and it's monstrous. It's huge and totally useless because that's not the way it works. What I have found is that most people have taken some chemistry in school and science.
What are the tax consequences of what we're talking about now?
Well, as I've just said, the energy market, the carbon market, is I think like the third largest market in the world. People are trading carbon credits, so you can put out a certain amount of carbon dioxide, and you've paid the taxes on it, but you can take that and you can sell it to somebody else at a big profit, and it's a gigantic. It's kind of like the bitcoins and things. It's kind of fuzzy, but in addition to that, all the things that we are required to do in our manufacturing and stuff like that add cost to everything, and the question is this, and it's all to avoid having carbon dioxide in the atmosphere on the theory that carbon dioxide in the atmosphere causes the Earth to warm.
Right.
And it doesn't. It's the other way around.
Oh, wow. Now, I understand that we recently had a gas tax increase, SB1, yeah. and there's an effort to try to repeal that. But I understand a part of that is to fight global warming,
yeah,
on the theory that carbon dioxide causes global warming.
That's right. Uh-huh. And it's worldwide. I mean, some countries don't go for it, but that makes it a gigantic financial thing. I don't know of any that's maybe building war equipment's maybe bigger, but
yeah,
but it's huge because it affects everybody and it brings up the costs of stuff. And the thing is, well, does it really?
Got you.
And
well, what are on taxes? can we say a certain percentage of all the taxes we pay are now wrapped into this global warming?
You probably could. There has been many reports of what the costs are, like in the United States or in California, and on the internet you can pick up other countries in the way that England and it's maybe might be a bigger market than hydrocarbons, oil. It's huge. And it's all based on a mistake.
Oh.
And that mistake is that, and anybody is, you have a soda pop, it's in the refrigerator, you pop the lid off of it, bubbles come out.
Right.
Okay, if you set it on a table or a beer, pour beer in a glass, bubbles form.
Right.
The carbon dioxide comes out of the solution when the solution warms up.
Yeah.
So if you have an ocean and you warm the ocean by some other means, the carbon dioxide that's dissolved in it will come out into the atmosphere. So you get a link between high carbon dioxide and warm water. But which is the cause and which is the effect?
Right.
The warming water causes the CO2, among other things. And the same thing on the surface, trees and stuff, as they change their temperature. And so that's what, and it's pretty easy to prove. But politically, not necessarily the thing that because it'll make a lot of people upset when the carbon things are not worth anything, possibly.
Okay, so let's
carbon credits they're called.
Let's restate the beliefs that are in this system, and some say it's ideological. They want to change the structure of Western civilization, and this is the only way they can think of doing it. There may be some other possible reasons why people would say something that's really not true.
Controlling people's behavior.
Right.
All kinds of stuff.
Industry.
Yeah. And that's all about power. And it's about money. And so even though it's pretty obvious, I believe, it should be obvious, that that's not the way things are. But I don't think there's any profit to anybody in actually going that way. A good example, and this is one experiment anybody can do. You have warm, if you take cold soda pop, take the lid off of it, carbon dioxide comes out as it warms up.
Right.
When the liquid warms up, the CO2 comes out.
Right.
The other way around, if you have a liquid with carbon dioxide around it, as the water gets colder, the CO2 goes in. And it's an exact equation. The temperature, water, CO2 is the exact scientific equation. So if you have an ocean, the entire Earth is covered, this big massive ocean. If the Earth warms up for some reason, the oceans warm up, the CO2 that is in the ocean comes out. If the Earth cools down, the oceans cool down, it dissolves carbon dioxide back into the ocean. There is a relationship, but it's the opposite of what we're being told.
I understand the ice cores, the Arctic ice cores show that.
Yeah.
So in the ice cores, they found numerous times where the Earth warmed, and the carbon dioxide content. There was a correlation. There's a relationship.
Yeah, but in science, it's what's the cause and what's the effect.
Okay.
And very often they get them mixed up. And
Al Gore did that in his videotape about an uncomfortable truth.
Mm-hmm.
He said you could see the association, but when you magnified it more closely, the global warming preceded the increase in CO2.
Exactly.
Again and again and again and again.
Exactly. But they kind of ignore that. But the question comes in. Let's see how I can do this. What does cause the Earth to warm?
The sun.
And why?
Radiation.
Well, that's what's coming from the sun. But does it actually? There is a point there. the sun's activity increases and decreases. At times, if you look through a filter, you can see sunspots.
Right. Lots
of storms on the sun, giving out lots of heat and energy, and that raises the temperature a little bit.
Right.
But it's also the distance. The Earth, is 93 million miles roughly to the sun, or vice versa. But it's not constant. It's actually the Earth's orbit around the sun is an oval like this.
Right.
Sometimes the Earth is very close to the sun, and sometimes it's further away.
Right.
When it's closer to the sun, guess what? It's warmer. And when that does happen, it's predictable because it's just astronomy. Now, CO2 comes out. It warms up. And when the sun is in this part of the orbit, where it's just further away from it, it doesn't. It cools down. And CO2 goes into the atmosphere.
How often is that cycle?
That's a year.
So every year.
But the cycle is about a year, but it drifts. So sometimes it's not quite a year, and it'll gradually drift around. So it's not as predictable as that because there are other effects. There's the Jupiter effect. There's all kinds of things in the solar system, which gravitational fields modify it. The Earth itself, as it's spinning, is tilted 27 degrees like this.
Right.
And it's spinning, and if the sun happens to be here, then the northern hemisphere is heated, and that not so. And the oceans here would be giving off CO2, but it might be colder over here. But it is that cycle of the Earth moving back and forth in this oval. It's not an orbit like that. It's an oval, closer to the sun, further away from the sun. And it's the absolute temperature of everything is 459 degrees below zero. That's ever. All the molecules stop.
Right.
So we're really quite warm compared to that.
Right.
And as a percentage change, it can be huge. So we get about 6 or 8%, depending, more sunlight when it's closer than further away. But since the sun is going on, less sunlight in a square, it's the square of 6, so it's 36%. So a huge percentage of the amount of heat coming from the sun is just this fluctuation with here and here and the tilting. And the Earth wobbles itself. Sometimes it's up and down, sometimes it's this way. So it makes it kind of complicated. And I guess it's too complicated for some people to notice. But the Earth, when it's closer to the sun, gets warmer. And it's not just proportional to the distance. Because we're talking about 450 degrees above, right now, 450 degrees above zero. Absolute zero. That's where all the molecules stop.
Right.
So it absorbs heat like crazy. And it turns out that is more, all by itself, is more than enough to explain all of the global warming major effects. But there's lots of little things that go on too. The Earth itself, as I say, sometimes it's vertical in spin. Sometimes it does this and like that way. Now, that's important because the sun is giving off particles, radiation, and it's moving at the speed of light practically, and it has a shock wave that goes around the Earth.
Yeah.
Okay, sometimes the shock wave is big, sometimes it's smaller, but it's huge. That makes a difference of sometimes 30 or 40 degrees.
Well,
it should. Now, but fortunately, the Earth has a capacity to hold heat, so we don't drop to 30 degrees below zero. We don't go up instantly. But if we were in that position long enough, you would. But of course, it keeps moving. It's a very dynamic thing. But it's the fact that our orbit is oval, not round, and the fact that the Earth is tilted, and so you get seasons as it spins.
Right.
And there are other fluctuations too, but that's the major one. And that alone, those numbers alone are enough to tell you what the temperature. But that cycle is a CO2 cycle. When it warms up, the CO2 goes into the atmosphere. When the Earth is in a cooler position, the CO2 absorbs back into the ocean. So it's been doing it for billions of years.
So the ice core samples prove that.
Yes.
Beyond a shadow of a doubt.
Yes, well, but there are other things going on too. So you got a lot of different kinds of noise, and it makes it a little more complicated because you get these other cycles that I can explain. But there's something. But we have noticed that there's this combination of CO2 and temperature, and so what? And here's a graph of time, 400 years and so forth.
You have to go a little closer to you.
Okay.
And
see, this is, and
I don't think.
Oh well, let me back up just a little bit.
They won't pick it up.
Okay, all right. Down at Caltech one time, and I had to go down there for some reason, and we were talking about this sort of thing, and it turns out. Let's see if I can. I'm kind of losing that. There's something else. There's something other than these solar cycles that's changing things,
right.
and so we get this. So the people at Livermore Labs started analyzing this. Now those are some brilliant people.
Right.
They make hydrogen bombs, and I was down there because of some anti-gravity things. But anyway, so it turns out they found. Well, let me back up a little bit. I'll leave it there. When I was in elementary school, they taught us that trees, during the day, absorb carbon dioxide to make the carbohydrates and whatnot,
right.
and give off oxygen.
Right.
My physics teacher said, "What do they do at night?" So that's good. I went out and I collected some air from trees at night. They were giving off carbon dioxide at night.
So they absorb carbon dioxide during the day,
and give it off at night,
and then give it off at night when it's cooler.
And the net effect was 0.
Okay.
See, so there's a seasonal variation, I should say. So that's an interesting thing. The trees.
Well, it could be 0 because the trees are composed of carbon, so then obviously it was absorbed.
Yeah, and but so most people are not. I guess most scientists don't go out at nighttime, but trees give off carbon dioxide at night and suck in oxygen at night. The opposite, preparing for the next day.
Wow, I didn't know that.
Yeah, see, well, think about that. Well, that's something going on there. So, what else happens? Well, they found when they get down again, the Livermore Labs, they started looking at it, and if you have a black object and the sun is shining on the black object, it'll warm right up. You get a black car, wear black suit, sun. The black stuff absorbs heat.
Yeah.
White stuff reflects heat.
Yes.
Okay, and variations in between. So if you had a black Earth and a warm Earth, and a white Earth, the white Earth would be cooler because it would reflect the stuff off, and the black Earth would be very hot.
Right.
Okay. You go out in the lava fields out down in California, they're black. Ooh, they get hot when the sun's shining on them. The white sand, no.
Okay.
So what's going on? So I took this little gadget here. I thought, went out, and at night there was a breeze going. And this measures temperature very, very accurately.
Hold it close to you and then be on the camera.
Yeah, this thing here very, very accurately measures temperatures from a distance, very accurately. So I measure the air, the temperature of the needles, leaves and stuff, if the air is coming in, and then I measure the temperature going out. The air coming out of the tree is warmer than the air going in. The tree is giving off heat.
He does at night?
At night. Well, but what's happening in the day? During the day, it's absorbing heat, but not as much because it's dark. So what it turns out is that if you looked at the Earth and you looked at places that were dark colored, those are going to be warmer than the light areas.
Right.
So if you have a forest of trees,
right,
it's going to be nice and warm because it's absorbing all that heat. And then at night, that heat is coming out into the air. It's nice and warm. And you think, that's interesting. So it turns out, and the guys out down at Livermore found the exact same thing. Trees give off heat. And this graph here.
That doesn't work. Lay it down.
Okay, there's a graph here that shows that when San Francisco was they were cutting huge amounts of trees to build San Francisco and stuff. They deforested California.
Okay.
California went into the deepest ice age. The miners were up here freezing to death. All the trees, and then after they got everything built, the trees started coming back, and the temperature came back to normal. It got really, really cold when they cut the trees down. When the trees were growing back, it got warmer again. Now, and I have lots of data to show it, all over the world, environmental, they're planting trees everywhere. And the more trees they plant, the warmer it gets. Because it stores it up during the day and releases it. And it exceeds. So basically, it's like you have a dark area where the trees are. It absorbs the energy and releases it at night. If you have a light area during the day, it doesn't absorb that energy. It doesn't release it at night. So and I did it myself accidentally. It came with this gadget here. Wait, that's right. So then I started researching it. So the people at Livermore Labs have now, you can look it up on the internet, anybody can do that. They're saying, wait a minute, it may be that all these cycles of global warming has to do with how much forestation and distortion. For instance, when people moved into Europe, they cut down trees and stuff for building their houses and stuff. Trees were gone. It got cold. And then later on, when they moved out of there, warmed back up again.
What about the Sahara Desert? Same
thing. Everywhere even in the desert, there's seasons there and so forth. And but forestation. So it turns out, according to Livermore Labs, maybe we don't want to be planting all these trees because they're doing it all over. It's like the thing to do. Let's go plant more trees. And the more trees they plant, the warmer it gets.
Now,
and that's a fact. I mean, that's measurable.
What's wrong with being warmer?
Well, good question. But when it does get too warm, then there's some kinds of animals don't survive very well. The fauna changes, so to speak, and that has happened. When the United States was first settled, the settlers came in, cut out a bunch of trees, and they built their cabins, and they used it to heat. And sure enough, it got cold. Then later on, when they all moved to cities, or they started using different kinds of energy, the fossil fuels and stuff, they're producing CO2. It got warmer again because the trees were there. The trees keep the world warm.
Okay, now, if you have a situation where, say, a forest is just eliminated in a fire, and so there is no more forest.
Well, at first, if there's charcoal and stuff, that becomes a heat absorber, which will be released and warm the area up. But then when it gets to be ash or just bare rocks and stuff, it doesn't absorb the heat as much, and you get cold.
Okay, so
it's of course more complicated than just a tree. It's because there's the whole environment involved there. And
we're talking about something global.
Yep.
So a forest fire in the Sierra is not going to significantly affect the global temperature in the world.
To some tiny amount, yes, it will.
Okay.
And it'll also have CO2, and people go, well, look, the fire burned and then the CO2 caused it. No, it's the trees are. So again, it looks very much like, and we can go back in history. We have these climate graphs that go back for thousands of years,
right.
And you can pinpoint. Be like an ice age might. Something happens, volcanoes go off, people migrate. There are all kinds of things that can cause trees to come and go. As the trees go away, the temperature goes down. As the trees come back, the temperature goes back up. And right now, it's rising very, very rapidly because we have, and it may be because we're no longer using the lumber. We're using different kinds of building materials, and that's worldwide. As we get away from using lumber, there'll be more trees left. As the trees, more and more trees are covering the ground.
Of course, they burn.
And next thing you know, it's getting warmer and warmer and warmer.
Now, I've seen demonstrations by advocates of global warming, man-made global warming, that they filled a bottle with CO2, and they proved that the CO2 was a greenhouse gas, but this was pure CO2.
Yeah.
Now, if you would compare, if that proves that it's a greenhouse gas, it's true that it is to some extent.
Yeah. The molecules vibrate, absorb the energy.
What percentage of the atmosphere is actually CO2?
And what is
it's
it?
not 100%.
2% or 4%. 2%, I think. I have looked at it. About 2%. And it depends on where you are. You have more oxygen in a forest. But it depends on night or day, too. It is very complex. The Earth is a very complex place.
Right.
But this tree effect is totally not expected, but it should have been predictable.
Right.
And then now, Livermore Labs, these powerful people saying, yeah, it's trees, folks. Among other things, there are other things going on. It's not just trees. But that seems to be, and their conclusion was, all over the world we have the green planting trees, and it gets warmer and warmer, and you can prove it with this gadget.
That's interesting. So it seems like everywhere you go now, they're saying the science is settled. The science is settled, but they say that 97% of the science...
That's a political statement.
Yeah, it is, well, apparently so. But they say 97% of the scientists have the opinion that man-made carbon dioxide is causing global warming.
That's true. And these organizations that list these things enlist them in their profession. They're biologists, and there are not very few physicists, very few geophysicists. They're biologists, and some of them are social scientists that claim that they're global warming experts and so forth. Now, I don't want to put down, because it makes sense, but the simplest illustration is soda pop. You keep it cold, it holds the carbon dioxide. The moment it warms up, it releases the carbon dioxide, and the reverse happens. If you cool it, CO2 goes back in. If the ocean cools, CO2 goes in. If the ocean warms, CO2 comes out.
Yeah.
And then in addition to that, then you get the tree things and all the other absorption things. But it is but this is a major factor.
That's interesting. I wonder how this can be disseminated.
Well, it's on the internet. These are people who are doing some serious stuff, and they have concluded totally, because originally they went along with everybody else. Yeah, global warming and now after they've actually made the studies, they realize that the reflectivity of the surface of the Earth, if it is important. If the Earth is dark, it doesn't reflect the heat.
Okay,
it stays.
If somebody wanted to get more information on this, they would Google Livermore.
Yeah, that would do. Global warming, trees, Livermore Labs.
Livermore Labs. Okay, you heard it here first. Well, Steve,
hopefully
you're doing wonderful work, and so glad you're a guest.
Right.
See you next time. Thank you for watching Taxpayer Alert.
Thank you. Thank you for doing all this.